Video we are looking at an example hess cycle. So in the question it's asking you to find the enthalpy of formation of butane. Once you know that the enthalpy of the enthalpy of combustion of butane is minus 2877 kilojoules per mole, the enthalpy of combustion of carbon is minus 394 kilojoules per mole, and the enthalpy of combustion of hydrogen is minus 286 kilojoules per mole. Step in that process would be to recognize what the formula for the enthalpy of formation of butane is. Well, the enthalpy of formation is defined as the energy required to make 1 mole of products from its constituent elements. Well, the constituent elements of butane are carbon and hydrogen, and I've got 4 lots of carbon and 5 lots of hydrogen. Once I've got the hess cycle set up, you can see that I'm using enthalpy of combustion data, so I know cats aren't dogs, the arrows have to go down. So I need my enthalpy of combustion for carbon. I need to multiply that by 4 because I've got 4 moles of carbon. My enthalpy of combustion of hydrogen, I need to multiply that by 5 because I've got 5 moles of hydrogen. And in my root 2, my enthalpy of combustion of butane. I need to multiply that by 1 because I've got 1 mole of butane. I can see in my final step the total enthalpy of combustion for 4 moles of carbon and 5 moles of hydrogen is minus 3006 kilojoules per mole. I know that the enthalpy of combustion for 1 mole of butane is minus 2087 kilojoules per mole. I know that it is independent of which route I take, so I look at which 2 arrows are pointing in the same direction. In this case, my delta HF and my root 2 are pointing in the same direction. So I've got X plus my value for the enthalpy of combustion of butane, which is minus 2087, is equal to root 1. That root 1 I got from over here, minus 3006. So therefore X is equal to 3006 minus 2877, so X is equal to minus 129 kilojoules per mole. And we can do this for any hess cycle.